Hello, this is Professor Urbis White. Today we are going to learn how to add and subtract radicals. Okay, let's get started. Now, if you want to add and subtract radicals, I just tell to my students in the class, instead of these radicals when they are the same index, use the distributive rule and pull them out, and you're going to have 2 plus 3. You can only do that when they are the same index. In other words, these two numbers are the same. And then you just go and add 2 plus 3, that's 5, nth root of a. Okay? If you want to remember that, you can also, instead of the radicals, you can say 2 potatoes plus 3 potatoes, you have 5 potatoes. This is just the like terms, and you can do it. But if the indices are not the same, like cube root of a and then 4th root of a, you cannot just write, oh, this is 5, oh, I don't know, whatever root of a. You can't just do that right now. Okay? So make sure the indices are the same when you add and subtract. Let's look at it. Again, the same thing. Indices are the same. Pull them out. 2 plus 3. So 5. It doesn't matter if it's square root, cube root. You have cube root of 5. Does it make sense? All right. Subtraction. The same way. When the indices are the same, just pull it out. 2 minus 3. So you end up with negative cube root of 5. So it doesn't matter. You have 2, 3, whatever. Okay? Or you're subtracting. Indices are the same. Use distributive rule. Pull it out. And you're done. All right. Well, what happens when you have a bunch of them? Okay? So let me get that out of the way. Okay, what you need to do, you need to look what is like terms, just like you do with polynomials. You have cube root of 5, cube root of 5. Pull that out. Cube root of 5. What do you have left? You have a 2, and then you have a negative 4. Now, let's pull that cube root of 7 out. What do you have left? You have 3, and you have a negative 5. So let's make it pretty. You have 2 minus 4, that's negative 2. Cube root of 5. Okay, 3 minus 5, that's negative 2. Cube root of 7. Okay? So that's it. That's the end of it. Well, how about when you have something more complex and you're kind of getting dizzy to look at? Xy squared. Is there another xy squared term? Here. Another one. Xy squared. And cube root. Okay, well, let's write those. So I have xy squared, and that's cube root. And what do I have? A 2, and I have a negative 4. Okay? And let's look at this one. It looks kind of similar, but it isn't. X squared y. So pull that out. X squared y. And that's cube root. Both of them cube root. Good. What do I have? 3 minus 5. And look what you have. Now 2 minus 4, that's negative 2. Cube root of xy squared. 3 minus 5, that's negative 2. Cube root of x squared y. Guess what? You cannot put those two together because they're not like terms. And that's the end of that expression. All right. I call these disguised cases. In other words, they look like they're not like terms at the beginning, but, oh, let's look a little deeper. When you have numbers, make sure you prime factor them. 254, again. 227, again. 39, again. 33. You prime factor them. What is that? 2, 2, and then you have 3, 3, 3. So let's put that in. You have 2 squared and 3 cubed. Okay? How about 32? 2, 16, 2, 8, 2, 4, 2, 2, 2, 2, 2, 2, 2. All right, let's put that in. Cube root of 2 2, 1, 2, 3, 4, 5 to the 5th. Let's clean it up. Is there anything I can take out? That 3 comes out, so I have a 3, and I have 2 squared in the back, and that's the 3rd root. Plus, remember how I used to do it with the radical notation? 2, 5 can split 3 and 2. So let's look at that. 3 and 2. And guess what? This can come out. So you have 3 cube root of 2 squared plus this 2 came out, 2 cube root of 2 squared. And all of a sudden I recognize it now. What happens to it? These two are the same. They didn't look like these were the same, but now I can pull it out. So 2 squared is 4, and you have 3 plus 2. 3 plus 2 is 5. The last step, 5 cube root of 4. All right, very good. Let's do another problem. This looks pretty complex. We're going to do it slowly. Let me put another paper underneath so I can do this problem all at once. The question is just subtract whatever you need to do and make it look a little prettier. 128, let's do it again. 264. 2 times 64 is 128. 232. 216. 28. 24. So I'm dividing everything by 2 each time. You have 1, 2, 3, 4, 5, 6, 7. All right? So you have 2 to the 7th. How about 16? 2, 8. 2 times 8. 2, 4. 2 times 4 is 8. 2, 2. You have 2, 2, 2, 2. There are 4 of them. So this is 2 to the 4th. Okay. Now let's write all this out. Okay. I will write the first one. Cube root of 128 is 2 to the 7th. X. Okay. Now, since this is 3, let's start doing those. Or maybe just leave it alone right now. Y10 minus 2x squared y. And now you have 2 to the 4th x squared y cubed. Now I'm going to rewrite it so that I have powers or groups of 3. So let's look at that. You have 2 to the 2nd power to the 3rd power. That will give me 6. I have one more, 7. Let's do the same thing with the 8. That's going to be x to the, you can do 2 and a 3. That will give me 6. To get to 8, you have another 2. Let's do the same thing with 10. You can go y to the cube to the 3rd. And now you have, I keep on making this bigger. This is 3 times 3 is 9. 1 is more, 10. I can do the same thing with this one. I'll group them in groups of 3. 2x squared y. Okay, groups of 3. Okay, what do I have? That is 3rd. Okay, so 2 to the 4th, so that's 2 to the 3rd and 2, right? So groups of 3. And how about x squared? I can't do anything about that. And y cubed is y cubed. So I'm going to take things out. Let's take this guy out. That comes out as, let's do it this way so we can see it. That comes out as 2 to the 2nd. This one comes out as x to the 2nd. So I did that. I did that. This stays behind. And let's do this one. That comes out as y cubed. And what do I have left? I have a 2 x squared y. All right, so let's do the same thing with that one. Minus 2x squared y. And then I will have, okay. Oh, this is y cubed. All right. Okay. Let's go. Negative 2x squared y. What do I have? I take this out. That's going to come out as y. And this 2 comes out. That will come out as 2. What do I have left behind? You're going to have a 2x squared. I need the y someplace. Okay. Oh, the original problem. So I think I changed the original problem, but I did not write this out. Yeah. Okay, I changed the original problem. I apologize for that. So here I changed it to 7 so that I have it. At the original problem, you have the 7. Okay, so let's go and change this to 7. All right, so this becomes, so 3 to the second power. Okay, so let's do it that way. 2 to the, okay, and then you have another one. Okay, here we go. Sorry about that. Okay, so when this comes out, it comes out as square. And you still have a y behind. So change this to 7 at the beginning. That will take care of it. Let's make it nice and pretty. So you're going to have 2 squared, which is 4, x squared, y cubed right here. Then you're going to have third root of 2 x squared y. All right? Now let's look at that one. You're going to have a minus 4 x squared y cubed. All right? So that take care of that. And then you're going to have a cube root of 2 x squared y. All right. So in the original equation, make sure you have a y10 and you have a y7 in here. And guess what happened? This is, and these two are exactly the same. So you get actually a 0. Okay? So that was kind of a complex problem. And this actually is the end of this session where you can actually manipulate things and add and subtract and put it all together.